working further on the downgrading of the beautiful old school Farnell sine wave oscillator that was made in the past for frequencies between approximately 1 Hertz and 1 megahertz. I couldn't repair it. There was much more about this in the earlier video about this problem. That's what I mean. So I decided to make a kind of hobby circuit out of this beautiful setup. And the best thing was that there was such a beautiful tuning capacitor here with a dial. You can see it here. It was also showed in the earlier videos. Anyway, I of course had to make an oscillator. And I made that oscillator with a field effect transistor. It's here. And there is much more information in the text box of this video. I made it with a BF256A. You can also use a BF245, A or B or C. And the tuning coil that makes the whole circuit oscillate is at the gate here, the gate of that field effect transistor. Between the gate and the source we have a capacitor of 220 picofarad, and between the source here and ground minus we have a coil. It's made with, say, very thin wire, ape hair wire. That's what I always name that, and 260 windings or 300 windings on a tube of 3 millimeters. And here you see how I've made that coil. This is, by the way, not 3 millimeters but approximately 5 millimeters, but that is not very critical. It's all about the amount of windings and the very thin wire that has to be used. Much more in earlier videos, also in my books, etc., etc. So this is the circuit that I'm going to use for the lower frequency bands, and then I mean, say, in the 100 kilohertz range. It works. By the way, the minimum frequency that I've tested starts on approximately 120 kilocycles. And then you have to switch this 1 nanofarad capacitor in parallel to that coil. And here at the input there is the, say, I call it here a test coil, but of course it is the coil that does the job. And I'm going to use all kinds of coils. That has to be, say, tested further. I made some first tests with these test coils to see whether this circuit could work between approximately 120 kilocycles and approximately 12 megacycles, and it worked. So for 12 megacycles, for instance, perhaps interesting to show when I can find it. I cannot find it at the moment, but I will take some time to show how the coil for 12 megahertz looks like. Well, take, say, a piece of wire and, for instance, a pencil. Oh well, this is the coil. Now I found it. That works here. This coil works and worked to get to 12 megacycles, with, of course, this tuning capacitor parallel to that tiny coil. This beautiful tiny coil. Of course, we can directly see that such a coil is critical. Say when a kind of wind blows along it, could be that we have an effect on the frequency. That's a kind of joke, but anyway, I only want to say that such a coil, when it's mounted in a certain situation, say with long wires or short wires here, that all will have an effect on the frequency range. Anyway, okay, well, there's not so much more to tell. Sorry for all the movements. Here is again that setup, and you can see here that I've mounted here a piece of wood, triplex, well varnished here. Here the oscillator circuit will be mounted, and here the coils will be mounted. So, the reason was that when I move the plates of the capacitor completely out, and I'm doing that here now, there was no room here to, say, mount an electronic circuit. At least in the way that I want to do that. So, that was more or less all. Thanks for watching. Finally, the schematic again, and I hope to have finished this project within a few weeks. Surely a very good usable field effect transistor, shortwave or medium wave oscillator. And again, for medium wave, use this 1 nanofarad parallel capacitor to get to, say, the AM band. The standard AM band going from, say, approximately 700 kilohertz up to approximately 1.6 megahertz.